I want to speak today in this presentation about excessive humidity in greenhouses, the cause, the problem, and the solution. The plant transpiration is the main factor affecting the level of humidity inside of the greenhouse. As you see, the huge amount of leaves per area, all these leaves are transpirating. As you see, the transpiration is a process that moves water from the root system to the leaves. In the leaves, we have the stomata. It's a small holes. They give the water vapor the ability to go outside. In the stomata, we have guard cells. It means these cells can close and open and give the plant the opportunity to take the water from the soil up to the air. All the water movement inside in the plants, especially, is the difference between the air humidity inside of the leaves. It's saturate, it's 100%, and the difference between the inside of the leaf and the outside. The outside, it's of course changing, and we can, when the difference is bigger, so the transpiration is higher. And we have all the joint forces between molecules inside of the water and the xylem. Is some factor, environmental factor that affecting the transpiration. Of course, we have the light intensity. When we have very high light up to the point of saturation, we have a process of opening the stomata, so the transpiration flux is increasing. The temperature, when the temperature is high, so the transpiration is high. When the temperature is low, it goes down. Air movement. You can see in this graph that when we move the air above the leaves, we can get 5 times more transpiration flux. This is very important. It's because the air movement take out the boundary layer. Boundary layer is a thin layer that are with a moisture, very high humidity. So when we take this layer out, the transpiration is rapid, but it's important because sometimes it's not allowed to a film of water, free water, sit on the leaves. So it's very important. And of course, the relative humidity. The humidity, when it's high, the difference is short, it's close, so the transpiration is low. When the relative humidity is low, the transpiration is high. Some other water losses from the plant. I must say that the plant can absorb something like between 2 to 5 liters per square meter per day. And only 1 or 2% from all this water, it's for internal purposes. In the plant, everything go outside because when the stomata is open, the CO2 come inside to the stomata, and of course the water vapor go outside. During the night, we have water losses from the plant, and it's more or less, it depends what crop, but in cannabis it's between 6 to 10% daily evaporation during the night. It's mean if we have, for example, 4 kilos per day, we have something like 400 grams of humidity during losses during the night. And you can see the small water tips on the leaf on the top. This is a very important process to the plant. When the plant, during the night especially, make osmotic transpiration, osmotic adjustment in the root system, this process take the water to the xylem in a pressure, and in the end of the leaves, we have aditotes. It's small holes in the epidermis of the plant, so the small drops of water go outside, and this is danger because most of the diseases need free water on the leaf, and we must dry it fast. The problem, it's a humidity-promoted disease. I want to speak about the big two. One, it's the Botrytis cinerea, or gray mold. It's a disease that affects during the cold winter or something like this. It's developed very good in between 10 to 20 Celsius degrees, and it's caused a lot of damages. We can see here conidia germination. We can see in the bottom of the picture we have conidia in clusters. Down in the picture you can see germination of the conidia. It's a spore inside of the leaves, and when it go down to the epidermis, it starts to make the damage. And the other friend is Alternaria alternata. You can see what damage they can do inside of the flower. It's a multi-host disease, and this one is expand very rapidly when the temperature are high. The opposite from the botrytis, it's developed very, very good, if we can say good, in 25-30 degrees Celsius, and it's declined when the temperature come above the 35 degrees Celsius. But anyway, it's not easy to control this disease, and it's this form of Alternaria alternata can produce human disease, allergic respiratory disease, and asthma. So it's a very dangerous. It's not only plant disease. The elegant solution and the best solution, it's not to spray. If you spray inside of the greenhouse, anyway, in the end, you have toxic residue inside of the flowers. So what we need is to fight it in a physical way. This way is mean dehumidification solution. It's mean you put an instrument, a device that take all the air from the leaves to the bottom of this device. Inside the device, condensate the water vapor, take it out, the free water from the greenhouse, and on the top of the device, we have warm and dry air. We have something else. When we grow in this system, we use a thermal screen. We can close the greenhouse, totally close. We don't need to ventilate outside anything. We just take out the humidity, and we stay with very efficient regime of energetic process inside of the greenhouse. I want to show you, for example, this is one of the graphs in warm temperature. You can see outside we have something like 80% of relative humidity, and inside we have 50–60%. It's we need to understand that it's very important not to get to the dew point. All the problems of the diseases, almost all of them, they are when we have a film of water on the leaves. This is the best place to germinate, and all the problems come after. When you have inside of flowers, and when the disease starts, it's not easy to repair it. So something else, it's again in cool temperature, we can see the same how it's working. It's a perfect line of low humidity inside of the greenhouse. DryGair solution is in a very wide range of crops, flowers, of course, cannabis, tomatoes, leaves, baby leaves, and basil. It's almost, it's a very good and very effective solution. Thank you.
Yep, like a question?
I wanted to ask you, do different strains of cannabis require different humidity levels to be disease-free? And if so, how does that work?
Well, when we are working with this device, we are working on the top, because the flowers come with clusters, and you have inside the trichomes and the leaves, and it's very humid place. So the solution of DryGair is to first moving the air in a very gentle way, and to take all the humidity from the flowers, from the leaves, to the machinery, to take out all the humidity, and we reduce. So we are not allowed to the humidity to create this problem with a film of water. It's just, and it's work in all this. We have a lot of experience in very wide varieties of from sativa, indica, and all this, and they are in a different shape and everything, and some of them are with a very compressed flowers, and some of them are more elongated, but it's working, and it's working very good. If we know, if somebody have very special requirement, we can adjust the machinery to the field. Thank you.
Thank you. Thank you, that was great.